Hello everyone. Okay, so this is a little video recording to help you if you had any trouble going over the assignment I gave you last week. The first thing I asked you to do was to calculate the inflation adjusted price for some car that I happened to buy in 1973. So I bought this car 1970, actually not the car, gasoline. I bought gasoline in 1973 for 50 cents a gallon, and you might want to figure out what that would be today. So the formula is you take the price in any year, let's just call it year X, you multiply it by the consumer price index in the present, and you divide by the consumer price index in the year that you had. And that will adjust the price just for inflation. So in this case, the price of gas was 50 cents a gallon and the year was 1973. So we need the consumer price index, which was 254.4. So that's the CPI for 2019, at least an estimate of it. And then we need, we need the CPI for 1973, which was 44.4. Alright, so let me get this out of the way, and now we can figure this out. You just take your calculator, which I don't have. Here, we'll use this one. So you just take your calculator, and it's 50 cents times 254.4 divided by 44.4. And that gives you an inflation adjusted price of $2.86 roughly. So gas in 1973 that most people assume was really cheap at about 50 cents a gallon, actually adjusted for inflation would be $2.86, and that's a little higher than it is today. To put another way, something that cost you $2.86 today would have cost you only about 50 cents in 1973. Alright, so that's the first kind of problem I asked you to work. The second problem was calculate the inflation rate between any two consecutive years, and we can do that in Excel. If I can get Excel to come back up here. So if you just look at this, you want to calculate the inflation rate between two consecutive years, say between these 2 years right here. Let's just call this inflation. Then we can't calculate it for years past, but the inflation rate for 2019 is simply the percentage change in the CPI from 2019 compared back to 2018. So the way you do that is you just take the difference in the two numbers. So I'm going to take this number and subtract the previous number. You take the difference in the two numbers and you divide that by the first number. And then if you want to put it in percent, you multiply the whole thing by 100. So the inflation rate that we expect for 2019 is 1.3%, and then you could just do that all the way down. You could get them all. So let me just see what that's about. I bet it's just crowding. Yeah, it's that. And this one's really weird. Let's get a little bigger. There we go. You can't find the inflation rate for 1801 because we don't have the 1800 number, so I'm just going to leave that one out. So these are the inflation rates that we've observed for, the last 200 years or so. You notice that in recent history it's been dancing around 2%. It was really low in 2016. There's a 2, there was a 3 in 2011. To get to some serious inflation, you have to go back to the early 80s, 81, 80, 79. So you can see there was a really serious inflation. It was because of that that most people think Jimmy Carter didn't get re-elected. He ran for re-election in 1980 and he was defeated by Ronald Reagan on a campaign to do something about inflation and the unemployment rate. Then If you go back and look at the Great Depression, it's quite interesting. The Great Depression was in the 30s. You see prices were falling. Later, when we get to the classical model of macroeconomics, you will notice that classical economics predicted falling prices when output is shrinking. So that's that. And then another really, I don't know what happened there. I really don't. Then if you go back to the American Civil War, that's 1861, 62, right in here, you can see these tremendous inflationary numbers there. And really, these are federal dollars, not Confederate dollars. The federal government was funding their side of the war by printing dollars. In fact, that's where that slang term comes from, greenbacks. And when you print dollars, it just creates a lot of inflation. When the war ended, they stopped doing that, and the inflation stopped really quite abruptly. So anyway, that's how you calculate the inflation rate for any 2 consecutive years. The third thing I asked you to do was calculate the inflation rate across several years. And you can't do that by averaging these things. So for example, suppose I ask you, hey, what's the average inflation rate from the year 2000 to 2019? Suppose I ask you to find this. A reasonable person would try to take these numbers right here, and they would do something like this. Just take the average of all these numbers and get this, and they would say the average inflation rate was 2.1% from the year 2000 to 2019. That's a fair number, but it's not quite right because of compounding. You can't take an arithmetic mean of these numbers because they're compounding on top of each other. A big inflation rate in 2000 becomes the base in 2001 and in 2002 and so forth. So arithmetic means won't work. Instead, what you need to do is you need to use a compounding formula. And the one we will always use in this class, and the simplest one, is just the present value. Let's do it the other way. The future value of something is equal to the present value times 1 plus the growth rate raised to the number of years out. So in this case, if we're trying to figure out the average inflation rate from the year 2000 to 2019, what we need is the CPI in the year 2000 and the CPI in the year 2019. And we're going to solve for the growth rate, and we need to know how many years out that is. Now you might think how many years out that is kind of simple, but it's actually a little bit tricky. Some students will count this year. They'll say 2000, 2001, 2002, and so forth, and they'll have 1 year too many. It takes 2 years to get 1 year out. So from 2000 to 2001 is only 1 year. So this from 2000 to 2019 is 19 years, not 20. If you counted up every year that's here, you'd see it's 20. No, it's only 19. From here to there is 19 years out. All right, so let's get those numbers. So let me see if I can slide this thing out of the way. No, I can't. Let's try it a different way. All right, so we need the CPI for 2019, which was 254.4. And then we need the CPI for 2000, which was 172.5, times 1 plus the growth rate raised to the 19th power. All right, so let me get this off of here so you can kind of see what I'm doing. Where'd it go? There, I hope you can see that. So the first thing I'm going to do is I'm just going to divide both sides of this equation by 172.5. So I have 254.4 divided by 172.5. So then I get something like this: 1.474 equals 1 plus the growth rate raised to the 19th power. Now some of you who've been a while since you've had a math class might be freaked out by this 19. Think of it simply. Suppose you had something like x squared equals 4 and I ask you to solve for x. You would just take the square root of both sides and you would get x equals 2. In this case, we don't have x squared. We got something raised to the 19th power. So what we want to do is we want to take the 19th root of both sides, And this is just a way to notate that, 1 over 19. So we're going to take the 19th root of both sides. On the right-hand side, that 19th power and the 19th root of it cancel out, and we're just left with 1 plus the growth rate. And on the left-hand side, we can do that in our calculator by, let me find that key. Oh man, where'd it go? Here it is, this thing right here. So I have that thing, shift here, 19th power, and I get 1.02065, something like that. Subtracting 1 from both sides, I get the growth rate is 0.02065. So that's the true average inflation rate from the year 2000 to the year 2019, 2.065%. And let's see, I've forgotten what Excel gave me. Excel gave me 2.1, so it's very close but not the same. And if I ask you to do this on the test, I would want you to use the compounding formula. Alright, so now the next question I asked you was, given an assumption of a particular inflation rate, for example 3.5%, can you calculate the CPI, what it will be in some year in the future, say 2025? Alright, so you do that the very same way. You use the same formula. Future value equals present value times 1 plus the growth rate raised the number of years out. And what we have is the current CPI, which is 254.4. And the growth rate was 3.5%. And now we need to figure out how many years out it was. Let's see, out to the year 2025. So this is 19, 20 would be 1, 22, 23, 24, 25. That's 5 years out. Make sure I did that right. 19, 20, 21, 22, 23, 24. 6 years out. 6 years from 2019 to 2025. And then I want to know what the future value is. So this one actually is kind of easy. All you do is it's 1.035, 1.035 raised to power 6. So now I get the future value is 254.4 times this thing, 1.229. So I get that with an assumption of an inflation rate of 3.5% by the year 2025, the CPI should be about 312.72. That's how you do that. The last question I asked you was, given an assumption of a particular inflation rate, can you calculate how long it will take for prices to double or to triple? So here's how you do that. You use the same formula. This one's a little harder because now we're solving for the number of years out. So you pick an easy price. I usually pick $1, but really you could pick any price, and then for it to double, this thing over here would be $2. So I think that's the easiest. But if you pick the present value of something was $5, and this number over here would be 10, just double. Then the growth rate was 3.5%, and we want to know how many years for this to happen. So this algebra is a little harder because the thing we're trying to solve is sitting up here in this exponent, so we have to use the rules of logarithms, and I laid them out in that video, so I won't write them again. But if I just take the log of both sides, then I have the log of 2 on the left side, and on the right side I have year times the log of 1.035, like that. And now I can divide both sides by the log of 1.035, and I get the log of, where did I get that 4 from? The log of 2. The log of 2 divided by the log of 1.035 is how many years out it is. So we can do that easy enough. Take the log of 2 and divide it by the log of 1.035, and I get at 3.5% inflation, it will take exactly 20.148 years. 20.148 years. Okay, so that's how you do that little assignment. I hope you could do that without watching this video, but if you got stuck somewhere, you would have, if this were a real class, you would ask me in the face-to-face class, you would ask me. So hopefully this video will help you. If you're still stuck on something, please post a question to me on the discussion board. All right, thanks.